Good morning, class. It is Thursday, April 2nd, and as you can see, I am venturing out into the wild outdoors while maintaining good social distancing, of course. And my job out here is to find instances where trigonometry can be used out here in the world in an attempt to make a video or two for you. So, I'm wandering around a random neighborhood, and I find these two very tall palm trees. And I think to myself, I wonder how tall those palm trees actually are. Now, not everyone shares my random curiosity. However, it's definitely possible that you would need to measure the height of these trees for some other reason. Say you're a contractor and your job is to cut those two trees down and you want to do it safely. Well, you need to know how tall the trees are, because if you don't, then those trees will fall onto that car and that house and that house and that truck, and it would be all kinds of bad, right? You need to know how tall those trees are, not only so that you know how many chunks to cut it into as you're cutting it down, but also to figure out what kind of equipment do you need. Do you need a truck that'll get you 100 feet in the air, or do you only need a truck that'll get you 50 feet in the air? Let's find out.
So because I don't have the ability to actually climb the tree with a giant tape measure and figure out how tall the thing is, I'm going to work on figuring it out indirectly. So what I did was I measured the street in the neighborhood, and it was right around 27 feet across. So there's 27 feet between me and the tree. Now, if I could somehow figure out this angle between my head and the tree, we should be able to figure out how tall that tree is. We just have to add 6 feet, because my eye, where I will be taking my measurements from, is right around 6 feet off the ground. And I actually drew this a little bit off, so I'm going to try this again. See if I can get that a little bit more parallel to the ground. There we go. Now, to find the length of the street, obviously I just used a normal tape measure. No problem. But to measure the angle from my face to the top of the tree, I'm going to use a tool that surveyors and explorers and sailors have been using for centuries, and it's called a clinometer. Clinometer like incline. To make a quick clinometer yourself, you can use a protractor and a piece of string dangling with a weight, so that when you tilt the protractor, the string will tell you what angle you have. These days we have many more high-tech options when it comes to clinometers, and in fact, I'll be using an app on my phone to get this done today. Okay, so here's the app that I'm using as a clinometer. As you can tell, as I tilt it, it changes the angle. So if I make my phone totally horizontal, it should say 0 degrees. And the idea is to hold it in such a way that I can look down the top of the smartphone and tilt that up until it's lined up with the top of the tree. But I want to do it really so that it's parallel with the ground when I start, and then look up to the top of the tree. Yeah, I know it looks kind of goofy, but I mean, again, it's what real surveyors do. They just have actual equipment that goes to their eye rather than holding up their phone to their face. Now, I did take footage of me finding this angle, but with the wind and everything, the sound was just awful. So just take my word for it when I say that the angle between my face and the top of the tree was right around 67 degrees. Okay? So what I'd like you to do is I'd like you to pause the video, see if you can figure out the total height of the tree. Now remember, whatever you get for h here, you're going to have to add 6 to it, because I'm taking the measurement from 6 feet off the ground, right? So whatever you get for h, make sure you add 6 to it. Ready, set, go. Now, this being a trigonometry word problem, probably not going to surprise you that we're going to use trigonometry. The question is, which trigonometric ratio do we use? And in order to do that, or in order to figure that out, we need to start with, what do we have? And what do we need? Now, there's a whole other video on naming these sides, the opposite leg, the adjacent leg, and the hypotenuse. And I'll go ahead and drop another link right now to that video if you have a hard time, or if you don't remember that. So from this 67-degree angle, it looks to me like what we have is this 27-foot adjacent side. I'm sorry, adjacent leg. Now, I keep doing that. I keep saying adjacent side, but I really need to be saying adjacent leg, because if you'll notice, yeah, this 27 is adjacent. This 27 feet is adjacent. It is next to the 67-degree angle, but the hypotenuse is also adjacent to it. So I need to stop saying adjacent side and start saying adjacent leg. Call me out on that in the comments when it happens. Okay, so I have the adjacent leg, which I just use ADJ to abbreviate. I'm looking for this height right here, which is the opposite leg. And I'm not particularly interested in the hypotenuse. The hypotenuse would be like if I wanted to attach a rope to the ground, to the top of the tree, for some reason, then I would need to know the hypotenuse to find the length of that rope. Okay, so we know what we've got. We know what we need. The next step is SOHCAHTOA. Yes, I write it every single time. So we've got the adjacent leg. We need the opposite leg. Which one of these three abbreviations has both A for adjacent and O for opposite? TOA is the only one that has both the thing that we have and the thing that we need. Okay? So we're going to use tangent. But remember, tangent is nothing by itself. We have to say tangent of, well, that looks like 67 degrees to me. So the idea is that this tangent of 67 degrees is the multiplier. It is the ratio between the opposite and adjacent legs. So we're going to plug that into our calculator in a minute. And that ratio is equal to the ratio of the opposite leg over the adjacent leg. So H is the opposite leg, divided by 6 is the adjacent leg. And then at this point, you can cross multiply. Don't forget when you cross multiply that if you don't have a fraction on one side, you still have a fraction on one side. You just have to put it divided by 1, and now, magic, it's a fraction. Okay, so 1 times h is h, that's nice. And I get 6 times the tangent of 67 degrees. Which makes sense, again, because tangent of 67 degrees is the multiplier to get from the small leg to the large leg, from the adjacent leg to the opposite leg. Okay, and now this is calculator play. So I'm going to jump over into Chrome. And I'm going to type in calculator. And it gives me this Google calculator. Now, if you're using this calculator, the first thing you absolutely have to do is look at this button right here in the very upper left of the calculator's keyboard. There are 2 buttons here. One says rad and one says deg. Deg stands for degrees. Rad stands for radians. They are two different units that you can use to measure angles. So far, we've only used degrees, so I'm going to hit that and see now how the degree sign is darkened, it's black, and the radian side is grayed out. You need to be in degrees or you're going to get weird answers. And that's kind of one of my big tips when it comes to these trig problems. If you get an answer that you really, really didn't expect, especially if you get a negative answer, I strongly suggest checking your calculator and making sure you're in the right mode. So it was 27 times tangent of 67, and I'm in degrees, equals 63.6. H equals 63.6 feet. So we're done, right? Well, no. But we're really, really close to done. We're almost done. Okay? Yes, the height of that right triangle is indeed 63.6 feet, but remember that I'm not taking my measurements from the ground, right? I'm not sticking the clinometer on the ground and measuring the height there. I am instead measuring from the height of my eye, which is, again, about 6 feet off the ground. So we're going to take that 63.6 feet and we're going to add the 6 feet for my height. So the tree is 69.6 feet tall. Nice. So I'm going to leave this up for a moment. Have a great one. Stay safe. Class dismissed.